In this video, we're going to talk about the two main classifications on how we might gather data for a statistical study. Those two ways are an observational study versus a designed experiment. So let's talk about what each of these are. An observational study. This is when we gather data without doing anything to try to influence the results. So if we're going to do a study where we look at people that were smoking and see if they're going to get cancer, we are not going to give them any medicine to prevent that. We are not going to try to get them to quit smoking. We're not going to try to do anything to influence it. We're just going to take our group of people and we are going to get data based on maybe when they started smoking, how long they've been smoking, if they get cancer or not during our study, etc., etc. We're just going to be gathering data based on how things are without trying to cause anything to change, without trying to, influence the results, but just gathering data as it is right now. On the other hand, the key difference between a designed experiment and the observational study is that we are going to introduce some kind of treatment and gather data about how the individuals respond to that treatment. So again, in the smoking scenario, maybe we would do some sort of incentive to try to get people to stop smoking. Oh, I can't even spell it all again. So again, the key word you want to think about the difference between an observational study and a design experiment is that we are going to be introducing some sort of a treatment. We are going to be doing something to try to affect the outcome, and we want to see what happens as a result. Now, in line with that, whenever we are gathering data, we are going to be breaking up our data into explanatory versus response variables. So the response variable, and we're generally going to only consider one at a time, although more complicated things you could. A response variable, this is the variable that we think will be affected by the treatment. Right, so we are going to do something and see what happens as the output. The output is called the response variable. The explanatory variables, and there could be more than one of these. These are the variables that we think will cause the response variable to change. So again, in the example, we're talking about smokers and whether they get cancer. An explanatory variable might be the number of years they've been smoking. We would think that someone who's been smoking 20 years would have a greater chance of getting cancer than someone who's only been smoking 1 year, for example. So that'd be an explanatory variable. And then we're considering our output being, did they get cancer or not? So that would be the response variable, cancer, yes or no. So we break things up. We have explanatory, we have response variables. We'll eventually learn how to do calculations with those, but for right now, we're learning terminology. Then we have confounding and lurking variables that kind of mess things up when you're doing these. So confounding, first off, this is when the effects of two or more explanatory variables are not separated. So the idea is you have these two different explanatory variables, and you go out and you gather your data and you gather your response variable and you see what's going on here. But it's possible that maybe there's more than just the number of years smoking are affecting the chance of cancer. Maybe the gender of the individual is affecting it, men or women, and maybe the age they started smoking, the age they currently are. Or maybe there's all these other things that are going on in there, and when you have more than one variable affecting the outcome and you're not taking that into account, that's called confounding. Now, lurking is part of this. So lurking is an explanatory variable that was not measured or considered in the study. So specifically, a lurking variable, this is an explanatory variable that was not measured or considered in the study. So if you have an explanatory variable that was not even dealt with at all when you were doing your data collection, that's going to be a lurking variable, and that lurking variable may cause confounding because it may be affecting the response variable. Maybe it doesn't. Maybe your lurking variable is hair color. Maybe hair color has nothing to do with whether someone gets cancer. On the other hand, maybe it does. I haven't looked in the studies. I'm not a medical doctor. But the idea is if you have this variable, it's a lurking variable, and then that may cause the confounding that is saying that when you have more than one variable affecting the answer and you don't take that into account, that's the confounding. So they're very closely related here. Lurking variables cause confounding, but you didn't have to be a lurking variable to create the confounding. Confounding can happen even with variables you did measure if you didn't try to separate out their effects. So all of these things are here for types of data collection we're going to do. Now there is one big data collection, and that's the word census. That is not something you are going to probably do yourself. So a census is gathering data from the whole population. So we talked about in an earlier video about the idea between sample and population, and how the vast majority of everything we're doing in this class is based on sample data because that's the only reasonable thing to get. It is very time-consuming, very costly, money-wise, to try to do census and gather census data. However, it does happen sometimes. Our country does a census every 10 years where they gather data from everyone living in the United States, and they use that for many things, including deciding how many House of Representatives each state will get. But with that said, it is costly. It's in the hundreds of millions of dollars range, I believe. Each 10 years our country pays that. And we certainly are not going to do it any more often than every 10 years. And if you want to do a census for anything, it's pretty much impossible. And even our government that does the census every 10 years, even though they spend so much money and they spend so much time and effort trying to get it, they still aren't going to get data from every single person living in the U.S., no matter how hard they try. So census is something that we'll do try in very, very, very limited circumstances, but it's pretty much impossible practically to do one. And even when we try, it's still not going to be a perfect census, but that's the idea. So census is like the perfect idea if it was free and took no time. You could get all the data about your population and be good to go. It's just not something very realistic. So these are our main ways that we're going to gather data.